Okay, picture this. A dark lab, late at night maybe. There's this hum in the air. And inside a glass chamber, you've got this tiny metal earth just hanging there.
Right.
Then Kristian Birkeland, this scientist, he cranks up the voltage. And bam, this incredible green light just blooms around the poles of the little model Earth. Silent, but, powerful.
Like a miniature aurora.
Exactly. It's like the sky itself just went, okay, fine, here's the secret. Our planet is basically an electrical instrument, and the sun is playing it.
That's a fantastic way to put it.
Welcome, everyone, to The Deep Dive. Today, we are really getting into the life and, honestly, the world-changing work of Kristian Birkeland. This was the guy over 100 years ago who completely flipped our understanding of how Earth connects to, well, everything out there.
He's a cosmos, yeah.
Our mission here is to explore how he took the aurora, this beautiful, mysterious thing, and turned it from poetry into hard science.
Right.
How he showed Earth is, like you said, a node in a cosmic circuit.
It's a great phrase.
We're using excerpts from Kristian Birkeland, 1867-1917, the man who plugged Earth into the sky. It's a fantastic source, really tells the story well. And we'll also look at his ideas through a more modern lens, something called motion theory.
Right, which helps us see just how far ahead of his time he really was.
Absolutely, because you'll hear how these ideas, which people thought were just crazy back then, pure heresy almost.
Well, definitely heresy to some.
They're now fundamental, cornerstone stuff for space physics today. And maybe we should just quickly say, motion theory, if you haven't bumped into it, it's basically a framework for looking at how energy and patterns move in dynamic systems, especially plasmas. Really helps make sense of Birkeland's work.
It really does, because Birkeland, he was standing right at this turning point in science. Before him, Earth was mostly seen as, well, just a rock, kind of isolated.
Floating in space, yeah.
But his work transformed it into this active player, an electrically charged part of a huge cosmic system. It's just an amazing story. Observation, brilliant experiments, and just refusing to accept that's just the way it is.
He wouldn't take mystery for an answer.
Not at all. He shows how one person asking the right questions, being brave enough to chase weird answers, can totally shift how we see reality, even when everyone else is saying, nah, can't be.
Okay, so let's dive into that. The 1890s. Science was booming, right?
Yeah.
We had gravity explaining orbits, Maxwell's equations covered waves, but the aurora, those lights.
Still a total puzzle. A beautiful puzzle, but a puzzle nonetheless.
People saw them, obviously, but what were they? Was it just heat, meteors burning up, some exotic gas nobody knew about? Theories were all over the place.
All over the place, exactly. Some plausible, some less so. But nothing really stuck. Nothing you could properly test. It was this gorgeous phenomenon that just defied a solid explanation.
And Birkeland comes along and makes this huge bet.
Or a radical bet, yeah. He basically said, forget local stuff. He theorized it was charged particles coming from the sun, hitting our magnetic field, a direct electrical link.
Sun to Earth, zap.
Pretty much. And he knew instinctively, I think, that just writing about it wasn't enough. He had to build it. He had to translate this big idea into, actual hardware, an experiment that could show the mechanism repeatably.
He wanted to replicate it, not just describe it.
That's the key. Understand the operating system, not just admire the display.
So he builds the terrella, little Earth, this magnetized metal ball, and a vacuum chamber. And then he fires electron beams at it, like the particles from the sun. And what happened? You said it was astounding.
It must have been. Because when those beams hit the sphere, these bright arcs of light just snapped into place. Ovals. Around the magnetic poles.
Just like the real aurora.
Exactly like the real aurora. He tweaked everything, moved the beam, tilted the sphere's magnet, changed the vacuum pressure, and every time these auroral ovals appeared right where the sky showed them, even if the existing theories said, nope, shouldn't happen there.
So it wasn't just a party trick.
No, far from it. It was basically, like you said, early analog computing, a physical model of a huge cosmic interaction shrunk down to lab size.
He literally bottled the aurora, showed it wasn't just some local glow.
Precisely. It proved the aurora is the atmosphere lighting up because it's carrying an electrical current, a current guided by the Earth's magnetic field lines.
Okay, so thinking about this motion theory angle. The electrons aren't just randomly bumping into air molecules.
No, not random at all. They get phase captured, as motion theory puts it. Think of it like they're forced onto these invisible tracks defined by the magnetic field, locked into a specific path.
Like a train on rails.
Sort of, yeah. Or maybe a better analogy from the source is a dancer following choreography. It's a field-aligned synchronization display. It shows how a fast, thin stream of energy, like the solar wind, couples its power into a slower, denser system, like our upper atmosphere. And where those two systems lock step, that's where the energy transfer happens, and you get light. The color is like the receipt.
A receipt. I like that. Green for oxygen, red for oxygen, higher up.
Exactly. It's the visible proof that energy just changed hands, that tension got resolved.
Okay, but here's where Birkeland really, threw down the gauntlet.
Right.
The part that really shocked people.
Oh, yeah. This is the big one.
It wasn't just saying the aurora was electrical. It was his idea of vertical currents. Currents flowing down along the magnetic field lines into the atmosphere and then back out to space.
Into and out of the Earth system.
Which sounded completely nuts back then. Heresy, like you said. Space was supposed to be empty. A vacuum.
The ultimate insulator, they thought. How could it possibly carry these massive electrical currents? It just flew in the face of everything they thought they knew about space.
So how did he even come up with that? He couldn't see them, obviously. No satellites back then.
Right, no direct measurements. But he looked at magnetometer readings from the ground during magnetic storms. He saw patterns. And from those patterns, he actually drew these incredibly detailed maps. Two huge systems of currents spiraling into and out of the polar regions.
He drew a circuit diagram for the planet.
That's essentially what he did. He saw the solar wind and its magnetic field as the generator, Earth's magnetic field lines. Those were the transmission lines, stretching way out into space.
And the atmosphere, the ionosphere, was the light bulb.
The load, exactly. The load, the part that glows when the current flows through it because it has resistance. He even talked about switches in the system, which we now understand as things like magnetic reconnection, these sudden reconfigurations of the magnetic field that release huge amounts of energy.
And years later, satellites go up there.
Decades later. And they find these currents, exactly where he drew them, behaving pretty much how he predicted. We call them Birkeland currents now. It's just this incredible posthumous proof of his genius.
Wow. Okay, so boiling it down, what's the big takeaway for us? The sun and Earth aren't just held together by gravity.
No, it's much more dynamic. It's an electrically connected system. Think of it, like the source suggests, as nested loops of energy flow. Fast, thin plasma streams from the sun transfer energy down these magnetic field lines,
The Birkeland currents.
into the slower, denser loops of our atmosphere. Energy is constantly flowing, and sometimes you get these big reconfigurations, substorms, massive sudden discharges of stored energy.
Which caused the really spectacular auroras.
Exactly. It's like our planet is plugged into this giant cosmic power grid, constantly humming, sometimes flaring up.
And understanding that is crucial for space weather.
Right.
Protecting satellites, power grids.
Absolutely critical. His work isn't some historical curiosity. It's fundamental to navigating our electrically active space environment today.
And Birkeland wasn't just a theorist drawing diagrams. He was out there doing it, building huge electromagnets.
Massive things, size of coffins, apparently. He was also pioneering X-ray tubes, high-voltage tech.
And then taking instruments he designed into the Arctic in winter.
Yeah, can you imagine? Dragging sensitive equipment through blizzards, setting up observation posts in the absolute middle of nowhere, freezing cold, just to watch tiny needles flicker on his magnetometers while the sky is ripping open with light above him.
He was literally chasing storms. He wanted to be inside the circuit.
That's what it sounds like. That dedication, that willingness to immerse himself. Motion theory calls that entering the loop, letting the system itself teach you, recording what it does, no matter how strange it seems.
There's that story about his tent blowing away in a storm.
Right, and he just digs his equipment out of the snow and keeps going. Incredible tenacity. But, his genius wasn't only pointed upwards, towards the sky.
Oh, what else did he get up to?
Well, he teamed up with an industrialist, Sam Eyde, and together they invented the Birkeland-Eyde process.
Birkeland-Eyde process. Okay, what did that do? Sounds industrial.
It was hugely industrial. Get this. They created a furnace with a roaring electric arc. Inside, basically controlled lightning.
Okay.
And used that intense energy to force nitrogen and oxygen from ordinary air to combine to fix the nitrogen.
Fixing nitrogen, like for fertilizer.
Exactly. Atmospheric nitrogen is abundant, but plants can't use it directly. This process created nitrogen oxides, which could then be turned into nitric acid, and boom, artificial fertilizer.
Oh, fertilizer.
Yeah.
From thin air.
Yeah.
Using lightning arcs, that's amazing.
It was revolutionary. Think about it, early 20th century, population growing, fears of food shortages because natural fertilizers like guano were running low. Birkeland's invention, born from studying space electricity, helped feed the world.
That's an incredible connection. From aurora physics to agriculture.
It really is. And if you look at it through that motion theory lens again, it's the same fundamental pattern, right? Taking wild current, chaotic energy in that arc, constraining it, controlling it, and forcing it to do useful work creating ordered chemical bonds.
Down-converting energy into something useful.
Precisely. Whether it's making the atmosphere glow or making fertilizer, it's about mastering electrical energy flows. Food from lightning, essentially.
So let's pull these threads together. Looking back at everything Birkeland did, especially with our modern understanding, what are the really crucial takeaways? What did he fundamentally prove?
Well, I think there are 4 really big ones, ideas that were radical then but are just fundamental now. First, space isn't empty. Obvious now, maybe, but not then.
Right, the vacuum idea.
Birkeland showed it's a medium, a conductor. It carries currents, patterns, energy. Motion theory might call it a presync motion substrate. Not empty, just ready for the electrical action.
Okay, 1. Space conducts. What's 2?
2. Geometry follows current. Those beautiful auroral shapes, they aren't random. The magnetic field lines dictate the shape. They channel the current.
So the shape tells you where the current is flowing, like a map.
Exactly, a topology map of synchronization paths, as the source puts it. It shows you the electrical highways.
Makes sense. Number 3.
3. Color is bookkeeping. We touched on this. Those specific greens and reds and blues, they're like itemized receipts.
Showing energy changing hands.
Yep. Visible proof of energy being transferred from the fast electrons to the slower air molecules. Each color logs a specific transaction.
Okay, and the 4th one?
4th, weather has a space side. The whole atmosphere, right up to space, is connected. It's not isolated layers.
So stuff happening way out there with solar wind and currents, it can actually affect things down here.
Subtly, yes. Motion theory talks about cross-scale entrainment. Solar-driven currents can actually influence atmospheric waves, chemistry. It's complex, not like flipping a switch for tomorrow's forecast, but the connection is real. Our atmosphere is coupled upwards.
Okay, so that clears things up. It's not just air glowing randomly, it's driven currents.
Right.
Organized electricity.
Right. And gravity might set the stage, keep planets in orbit.
It builds the scaffolding.
Yeah, good way to put it. Gravity builds the scaffolding, but electrodynamics runs the wires, the plumbing. It directs the energy flow, the traffic.
Which makes Birkeland's work totally central, not some weird fringe idea.
Absolutely mission critical. For understanding space weather, protecting our tech, seeing Earth as part of this bigger dynamic system, he laid so much groundwork.
So, Kristian Birkeland, the electrician of the heavens. It really fits, doesn't it? He basically grabbed a wire from the sun, plugged it into the Earth, and said, okay, listen to this.
Yeah, pretty much.
He showed us the aurora isn't just pretty lights, it's a live electrical connection. That space isn't empty. It's alive with currents, and the colors are energy moving along specific paths.
He turned the sky into a giant voltmeter, the coals into a cosmic dashboard, made the invisible visible, measurable.
And maybe even steerable. That brings us to the really mind-bending part, looking forward.
Right, where could this lead? His legacy isn't just explaining the past, it opens doors. What if, for example, we could get so good at reading those magnetic field signatures, the coherence depth perhaps, that we could predict exactly how long a specific auroral arc will last?
Like forecasting individual auroral features.
Potentially, yeah. But even wilder. What if we could use powerful ground-based radio transmitters, these heaters, to gently nudge the ionosphere to create tiny artificial irregularities and actually steer where an auroral arc goes to demonstrate real path control in this massive circuit?
Wait, actually guide the aurora?
It sounds like science fiction, I know.
But if we could do that, it would prove an incredible level of understanding, maybe even interaction. Imagine catching a whole sun-to-earth energy cascade, from solar flare to atmospheric response, and seeing our influence in it.
That would turn Birkeland's amazing insights into an engineering diagram for how our planet interacts with the solar system.
Exactly. How would that change how we see Earth and our place, electrically speaking, in the universe? It's a profound thought to leave people with.